Okay, so yesterday our lesson was a lot of information to digest. So let's kind of just go back and think back to the things that we talked about that we need to know when we are graphing a rational function. Okay, so the first thing we talked about was the domain, and the domain is the values that are exclusions. Basically, that means what value makes the denominator 0. And we always write this in interval notation. And we write this before we do any simplifying where we cross something out at the top or the bottom. Okay, so that's our domain. The range, we always do this last, after we have all of our asymptotes, after we have our domain, our intercepts, all of those things. We go back, we look at our graph, and we decide what our range is. Remember, the range is our values of y, in case we forgot. Kind of like the domain is all values of x, range is all values of y, and again, we also do this in interval notation, just like we did with the domain. Okay, and then kind of keeping on moving through here with our values we need to find, our x-intercepts. Okay, those are the value of x when y equals 0. So that basically just means we're going to take our equation and we're going to take out y and put 0 in its place, and we're going to solve, and it is listed as an ordered pair. So when you do your Classkick, things like that, make sure you're listing it as an ordered pair, not just x equals 5 or something like that. Okay, then coming back over here to y-intercepts, those are the values of y when x equals 0. So we're basically going to take out x, put 0 in its place, and figure out what y is. And again, that is an ordered pair. Okay, so those are some things that we've talked a lot about throughout the course of this year. X-intercepts, y-intercepts, domain, range, we've talked about all those things. We've talked a little bit about asymptotes before too. But just a reminder, a vertical asymptote is always written in the form x equals, and remember, a vertical asymptote goes vertically through the x-axis, things like that. So, and where we get our vertical asymptotes is it's the exclusions from the domain. So these, where we got our exclusions, it's the exclusions from the domain after simplifying. So after we cross out anything, things like that, then anything that's left in the denominator that it can't be, that's going to be our vertical asymptote. Our horizontal asymptotes, these are a little bit tricky. Okay, there's two ways you can find horizontal asymptotes depending on the type of equation that you're given. Okay, if the degree of the numerator and the degree of the denominator are the same, so there's a squared in the top and a squared in the bottom. It's a first power in the top and a first power in the bottom. Something like that. Then you use y equals a over b, where a is the lead coefficient of the numerator, b is the lead coefficient of the denominator. The other type of horizontal asymptote you might be able to find, or you might have to find, is if the degree of the denominator, so the denominator degree is larger or greater than, so remember this right here says greater than, so the denominator degree is bigger than the degree of the numerator, then it is always y equals 0. And then the other, so that's the other type of horizontal asymptote. The other type of asymptote you might find is if you have a slant asymptote. Okay, a slant asymptote is when the denominator is less than the numerator. So you'd have to actually use polynomial division to figure out what the equation of that line is, of that slope, or excuse me, of that slant asymptote. And we'll get to doing a couple of those examples like that here either today or the next day. So we haven't spent a whole lot of time talking about that, but we will. And then the holes are the values where the numerator and denominator have a common factor. So like if we had, so if when we have it all factored, x plus 1, x plus 2 over x plus 2 or something like that, if we cross out x plus 2, that means that we have a hole at x equals -2. So that's how our holes, and again, holes are not in every problem. We won't see them every single time, but they do come up every once in a while, and we just put a circle there to indicate that there's a hole there. So we will be coming back to these 2, 4, 6, 8 ideas on every single graph that we do. So this is a slide right here that you probably want to have access to pretty easily so that if you're not sure how to find some of those things, you can easily do that. Okay, so let's get started on actually figuring out one of these. We've got f of x equals 2x minus 1. Okay, so first of all, let's go ahead and find the domain. So we find the domain by figuring out what x can't be. Well, if x is in the denominator, it's just x. There's nothing added or subtracted to it. That means x cannot equal 0. So in interval notation, that means we would be going from negative infinity to 0. And then we're going to jump over 0, and we're going to start again at 0 and go to positive infinity. Okay, so these, again, soft parentheses mean that it does not include 0, so it goes all the way up to 0, does not include it, and then keeps going on forever in the other direction. We are going to come back to range after we are all done and we've got it all graphed and stuff. Then we're going to look at our graph and decide what our range should be, so let's not forget to do that. Our x-intercepts is the value of x when y equals 0. So we're going to have 0 equals 2x minus 1 over x. I prefer to think about these as a proportion. If I do the butterfly method here, x times 0 is just 0. 1 times 2x minus 1 is just 2x minus 1. If I add 1 and divide by 2, I get x equals 1/2, which means my x-intercept, again, is an ordered pair at 1/2, 0. So let's go ahead and put that guy down here on our graph at 1/2, 0. So that's our x-intercept. We have one little point that we know so far. Okay, so far we've figured out the domain and the x-intercept. Okay, our y-intercept, again, is our value of y when x equals 0. So we're going to have y, go back to our equation, y equals 2 times 0 minus 1 over 0. Well, we got a little trouble here, don't we? Because we can't divide by 0. So what does that mean if we can't divide by 0? That means that there is not a y-intercept. A y-intercept does not exist, or there is none, however you want to say that, because you can't divide by 0. Okay? So we have no y-intercept, so there's nowhere we need to plot a point for that. Our vertical asymptote, again, our vertical asymptote is pretty much just our restriction that we had up there after it was simplified. We couldn't simplify anything from the very beginning, which means our vertical asymptote is at x equals 0. Oops. Okay, so let's see. So we have x equals 0. That's a vertical line here. So I'm going to draw my vertical asymptote in there. Okay, my horizontal asymptote, well, my degree of my numerator is 1. The degree of my denominator is also 1, which means that my horizontal asymptote is going to be y equals a over b, which is 2 over 1. So my horizontal asymptote is at y equals 2. So let's go ahead and put my horizontal asymptote in there at y equals 2. So we're going to go like this and go horizontally here at y equals 2. Okay, so now we're getting somewhere with our graph. A slant asymptote. Okay, so remember the slant asymptote is if the degree, let's see, what was it? The slant asymptote is if the degree of the denominator is less than the degree of the numerator. Well, the degrees are the same, which means there is no slant asymptote, which means there's none. We say it does not exist or none, whichever, either way. And then our holes, again, not in every problem, but our holes are going to be where if we did simplify anything, then we would have a hole at that position. And there is nothing that we simplified from the very beginning. So again, there are no holes. So this is going to be a none or does not exist. And then we can actually use our graphing calculator to help us know where the branches of this graph is. So if you want to take a second and and pull up your graph on your graphing calculator or something, you'll be able to use the graphing calculators to help you with these a little bit. So that's fine. But just make sure you know how to find all of the rest of this information with the work provided. So let's go ahead. Using your graphing calculator, you're going to have two branches. One branch is going to be over here. And remember, we do not touch those asymptote lines. And then our other one, we actually do, remember, have this little x-intercept. So we're going to cross through that x-intercept and we're going to whoosh, and we have these two branches on each side of our asymptotes. So then what we can't forget when we are all done is we can't forget to go back and do our range. So if you look at our range, okay, remember you read the range from the bottom to the top. So if you start down here at the bottom, and you work your way up, you have a graph from negative infinity and then to 2. So that's going to be, there's no graph at 2, and then it keeps going all the way to positive infinity. So when we write what our range is going to be, we are going to go from negative infinity. It went up, 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 up until it hit at 2. Remember, it didn't cross 2 because 2 was our asymptote. And then it went from 2 to positive infinity. So what you should do now is after you have finished this part of the video, go ahead and stop. And there's a couple of problems on the Classkick that are similar to this that you should be able to complete based on the information that we did in this problem. So go ahead and stop the video here, do those next couple of slides, and then we'll have another video.